When we re-examine the journey of the universe through the stars with the eyes of science, what kind of shocking experience will we get? Let's assume that at this moment, we board the Eternal ship with a group of cool guys and set off for the mysterious wormhole near Saturn. This journey is expected to take 2 years. We will consider their orbital radius and calculate the speed of the spaceship so that the Eternal ship has traveled 1.3 billion kilometers in 2 years. Its speed is about 70,000 kilometers per hour. In the history of human spaceflight, the fastest carrier spacecraft is Apollo 10. Its speed is 40,000 kilometers per hour. According to the development trend of human technology, it is not impossible to achieve such a speed in the future. And the most unique design of the Eternal ship is its spectacular rotating ring structure. It generates man-made gravity through the Liexean effect. According to the Liexean acceleration calculation formula, the time of the spaceship's half-circle rotation is 5.7 seconds, and the rotation per week is 11.4 seconds. In order to generate the same gravity acceleration as the Earth, the radius of the spaceship needs to reach about 30 meters, which is nearly 60 meters. For reference, the width of the International Space Station is about 70 meters, so this setting is scientifically reasonable. When the Eternal ship arrives at the wormhole near Saturn, we will face one of the most fascinating time-space structures in physics, the wormhole. This can connect the three-dimensional tube structure of distant space, not only allow the spaceship to travel in it, but even the light can move inside it. So through the one end of the wormhole, we can see the other end of the scene. In order to simulate the visual effect of the wormhole, we first smooth out the cylinder of two spaces in space to get a better transition effect. Then put a camera at one end of the wormhole and a starry sky image at both ends, so that the camera can receive the light on both sides at the same time. In this way, when the light reaches the camera, it can be converted into the corresponding pixel. Through light tracking technology and the sideline equation in the general relativity theory, we can track the movement of light in the twisted spacetime, and then calculate the position of each pixel and the color received by the camera on the pixel and then dynamize it. Then we get the simulation of the wormhole. At this time, we will be surprised to find that the simulation image is very similar to the special effect of the wormhole in the movie. However, after we change the geometric shape of the wormhole, we will find that it is not exactly the same as the wormhole in the movie. Maybe it's Nolan's intention to let the audience see the more shocking visual experience of the spaceship crossing the wormhole along the cylinder. If we really go through the wormhole, we may see the magical scene inside the wormhole. After leaving the wormhole, Eternal came to the area near the super high-quality black hole Kagan-Tuya. There are several planets orbiting the black hole. The most special of them is the Milky Way. The surface of this planet is completely covered by seawater. Its orbit is very close to the black hole, resulting in not only extreme tidal phenomena, but also a huge wave of up to 1 kilometer. And the time expansion effect is extremely significant. 1 hour on the Milky Way is equivalent to 7 years on the Earth. Through the gravity of the black hole and the centrifugal force produced by the orbit of the planet, we can use classical physics to calculate the tidal force and thus calculate the distance from the Milky Way to the black hole. In the movie, the quality of the black hole in Kagan-Tuya is 100 million times that of the Sun. It can be calculated that the Milky Way is about 450 billion kilometers away from the black hole, and the radius of the black hole is about 300 million kilometers. When we compare this distance with the picture in the movie, we can find that it is very close from the perspective of watching the black hole from the Milky Way. However, the time expansion in the movie is set in reality and is difficult to achieve. For a static black hole, when we bring the distance into the calculation time expansion formula, we can get that the time expansion of the Milky Way is only 1.05 times. If we want to reach 60,000 times the time expansion, the Milky Way must run on the light layer of the black hole. But in this position, only light can move stably. No planet can exist in this area. According to the theory of relativity, the high-speed rotation of the black hole can make the orbit around it more stable. If we want to achieve the time expansion effect in the movie, the Milky Way needs to be 6,000 kilometers away from the edge of the black hole, and the rotation speed of the black hole must be 1/10 slower than the speed of light. So, this is obviously an exaggerated visual effect. Then we followed Cooper to the black hole. The scene of Kagan-Tuya is extremely shocking. So here's the problem. Is the real black hole like this? In order to simulate the real picture of the black hole, we will use the light tracking technology and the sideline formula to get the simulation picture of the black hole. We will find a bending phenomenon behind the black hole plate. That's right. This is Einstein's gravity penetration effect. Due to the strong gravity of the black hole itself, the light around it will shift, so that the object we see is actually in another position. But this phenomenon is not reflected in the movie. At the same time, there is a suction plate around the black hole of Kagan-Tuya. By simulating, we can see that the gravity of the black hole twists the light emitted by the suction plate itself, and the rotation speed of the suction plate is very fast, almost close to the speed of light. Under constant friction, the temperature of the suction plate can reach tens of millions of degrees Celsius, and a strong and fatal radiation is produced. After filtering out the light outside the visible light, the plate presents a high-energy blue light. This explains why the high-temperature star emits blue light. At the same time, due to the fast rotation speed of the suction plate, the light on one side of the plate will look brighter than the other side. This is the famous Doppler effect. But this phenomenon is not shown in the movie. In order to get rid of the gravity of the black hole, Cooper decided to reduce the gravity of the eternity and enter the event world of the black hole alone. In theory, the starting point of the black hole is a dot. But research shows that the starting point of the black hole will show the twisting structure of the chaos. When matter falls into a black hole with a very fast rotation speed, due to the effect of time expansion, the matter inside the black hole is relatively slow in motion and constantly accumulates, eventually forming a large-scale starting point. This starting point is relatively gentle, and the gravitational force produced by it is also relatively weak. But in order to prevent being caught up by another starting point, the eternity must enter the black hole at a speed close to the speed of light. Cooper used this to survive. Because the movie hopes to show the multidimensional space-time structure mentioned in the theory of hyperspace and the theory of magic and quantum hidden effect, Nolan imagined that Cooper would enter a four-dimensional superquantum body. The object is set up to have the same creature as the cosmic quantum body placed there. Each side of it is a three-dimensional quantum body. This structure allows Cooper to travel a long distance to reach his daughter's room. This is theoretically possible because light can be transmitted to Cooper's vision on the surface of the universe. But in the movie setting, Cooper's light cannot be transmitted to his daughter's room, so they cannot communicate directly with each other, until Cooper discovers that gravity can cross this obstacle and transmit information. He decided to use gravity to transfer quantum data to the three-dimensional space to help his daughter master the method of controlling gravity, which eventually reduced the gravity on the surface of the Earth, so that the plot can be sent into space from the Star Space Station, and thus save human civilization. Although the technology in reality has not yet reached the level of the movie, this journey of science and imagination not only shows the scientific plot in the movie, but also makes us look forward to the future technological development. Through the eyes of science, we can understand and appreciate the charm of this movie in more depth.